Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Yes, tonight we are looking at this question. It says, a car and its driver of mass 700 kilograms is moving at constant velocity of 30 meters per second. The driver notices the stationary truck blocking the road and applies the brakes to slow down the car at constant rate. The driver is alert and his reaction time is 0.7 seconds. Okay. Then the question says, how far does the car move before the driver applies the brakes? Okay, when you look at this question, something must come into your mind. What does the question want? The question wants the distance, first of all. What distance? I want you to know that there is that time lag between our decision and our application. This one is biological. It comes from the fact that whatever execution we are going to make is supposed to be done by movement of impulses. And impulses take small time to reach the target. And even if they reach the target, the muscles and other reacting entities also take time to react. So in other words, what I'm trying to say is that there is a time lag between our decision and our application of the decision. So this driver was driving at constant speed and he saw the truck blocking the road. He made a decision to slow down and he applied the brakes. So look at here, the brain receives the impulses, it sends down the impulses to the legs and applies the brakes. That one took, is what we call reaction time, and it took 0.7 seconds. The question is, in 0.7, what was happening? The car was still moving at the same speed, the same velocity. So we are looking at a situation of constant speed or constant velocity. The equation for constant velocity comes from this equation. It's an equation of motion. It says delta x is equal to vi delta t plus a half a delta t squared. This equation is going to be our part in the next chapter, which I'll be discussing again here, which you call projectile or vertical projection. Now, I want you to analyze this part. What we have here in this equation is acceleration, and the constant velocity means 0 or 0 acceleration. So what does that mean? That the acceleration here, we have here, is 0. 0 implies that the entire factor here is 0. So what are we remaining with? We're remaining with an equation which says delta x is equal to vi delta t. This equation we've been using it since primary school. It's the one which says s times t is equal to d, where in that case s is the speed and the time, t is time, and d is the distance. So it's the same expression, though here we just change, we use different labels. Okay, That's the explanation. But now let us go to the question. What do you have of this? They are looking for delta x. We don't know it. Okay, it's the distance. But what else do we know? We know that the velocity at which the car was moving, and the velocity is 30 meters per second. What else do we know? We know the time taken for the reaction to start applying the brake, and it's going to be 0.7 seconds. So with that information, what do? We just substitute and we say delta x is equal to 30 times 0.7, giving you 21.00 meters. Then comes our next question. It says the time taken to bring the car to rest is 6.5 seconds. Use the impulse momentum theory to determine the force required to stop the car. What we call impulse momentum theory is this. And they want us to use it to determine the force needed to stop the car. Okay, let's check what we have here from the information. Okay, first of all, let us see. You have the mass. The mass is 700 kilograms. What else do we know? We know the initial velocity, which is 30 meters per second. And we also know the final velocity. Final velocity, we get it here. Stop. Stop means 0 meters per second. Okay. And we know the time. The time is 6.5 seconds. Now, from this expression, when you look at this data, it implies that we can change this expression to become F net delta T. So you open up change in momentum to become mvf minus mvi. We do that together for the information we have here. Okay, let's check. Do you have time? Yes. Do you have mass? Yes. And both velocities are known. So what are you going to do? To substitute in. And you are going to say F net times 6.5 is equal to mass, which is 700, times final velocity, which is 0, minus 700 times 30, which is the initial velocity. What we have here is going to be 6.5 F net, giving you negative 21,000. Okay, from here, now we have our F net. Our F net is going to be negative 21,000 divided by 6.5, giving you, let's see what we get. So that is what we have. But the question, it's not looking for net force. The question is looking for force brakes. How do you go about that? To approach this one, you need to have your free body diagram. Our assumption that suppose the body is going that side, and during the time of applying the brakes, this is what we have. You have force brake as that. You have other forces which are acting vertically, the normal force and the gravitational force, but I'm not going to put them. This is the only horizontal force which is acting during the time of braking. Okay. And what do we know? We know that F net is equal to the algebraic sum of all the forces which are acting here. So here F net is going to be negative FB. So our F net is negative FB. So what are you going to say? You come here and say F net, which is negative 30.76, I'm substituting for F net, is equal to negative FB. And force brake, now we have it. We are going to get 3,230.76 is equal to force brakes. Yes, that's what you are supposed to go through to get that. Yeah, then comes this question. It says, state 4 precautionary modifications on or in the car to minimize injuries, stroke death during collisions. Yeah, what are these modifications which are made on the car or in the car to minimize death and injuries during collisions? Okay, the first one is seat belt. Okay, the next one is airbags. The other one is arrestor beds. Actually, this one is not on the car. It's outside. It's the design of the road to make sure that when the brakes fail, the situation does not turn catastrophic. Okay, the other one is crumple zone and others. You know, with technology, everything, new things are coming up. Yeah, then comes this last question. It says, explain the basic principle on which the modifications above work. Yes, the seat belt, the airbag, the arrestor bed, the crumple zone, they work basing on what principle? Okay, they work basing on this equation. F net is equal to delta P over delta T. So when time increases, F net decreases. And when time increases, F net decreases. And you have to know that all the injuries and most of the death, the cause is net force. The bigger the net force, the higher the chances of the person to become severely injured. So what do these things do? So this is what they do. They increase the time of contact and so decrease the net force. Net force and time are inversely proportional. And with that, would like to thank you for your time. The channel is PSSB. Don't forget to subscribe Don't forget to like and also to refer the channel to a friend. See you next time. Bye bye.